3 and negative 4 are constants. Right? 3 and 4 are constants. 3 and 4 are terms themselves, but 5 is not a term itself. 5 is multiplied with y. So 5 and y cannot be separated. Same thing for 10y. Multiplication, like a glue things together as one term. So 5y is one term, 10y is one term. Positive 3 is one term, negative 4 is one term. Right? So 5, 10 called the coefficient or scalars of y. And 3, so what does 5 do? 5 make y 5 times bigger. 10 makes y 10 times bigger. Right? But the positive 3 and negative 4 are constants. They do not change. Right? Make sure we see the difference. So how do we solve this? I like to see move things around. Because we have equation, right? We have equation, we can move, terms from left to right, from right to left. And when we move around, what do? We just change the sign. We just change the sign of the term. Let's see this case. I want to move 5y to the right-hand side. So 5y is positive on the left-hand side. When I move to the right-hand side, it becomes negative. So I have 10y minus 5y. I have 10y minus 5y. Because 5y was positive on the left. When I move to the right, it becomes negative. At the same time, I could move negative 4 to the right-hand side. Well, negative on the right-hand side, when I move to the left-hand side, it becomes positive. It becomes positive. So I get this. I get 3 plus 4 equals to 10 minus 5y, which is 5y. Well, 3 plus 4 is 7, so 5y equals 7. That divided by 5 on both sides. Divided by 5. Well, 7 equals to 5y is exactly the same as 5y equals to 7. When it's an equal sign, we can swap, from left to right. So when we divide by 5, so we get 1y equals 7 over 5. So we don't bother to write this one. Right? Just y equals 7 over 5. At any time, if you have any question, just stop me, okay? Just speak out or type in the chat. Why is it positive when you move it over? Okay, let's see. Let me give you an example. Let's do over here, actually. Let's say I have 1 plus 2 equals to 3, right? Now you see 1 is positive. When I move, if I move 1 to the other side, I have to change it to be negative. Right? When I move this 1 to the right-hand side, it has to be negative because 2 equals to 3 minus 1. Does it make sense? Aisha?
Yes.
Yes,
Professor.
okay. Okay, all right. Well, you can tap in the chat. Yeah, that's why. So let's make another example. Let's see, we have 7 minus 5 equals to 2, right? I want to move negative 5 to the right-hand side. So when I move, I have to change negative 5 to be positive. Because 7 equals to 2 plus 5, all right? So, right, I like to teach. Yes, questions?
Yes, questions?
Okay, Aisha, I'm gonna mute Aisha.
Professor?
Yeah.
I have a question about the last equation. So when
Okay.
we're doing it, are we also able to do plus 4 to the other side, and then divide by 5.
You mean you want to do the same at the same time? Let me type in here. You want to do move 4 to the left hand side, and move 5y to the right hand side.
Oh, you would move both of them at the same time.
You could move around same time, different terms.
Okay, I thought we had to divide each side by 5 to get 5y from 1.
When can we do that? Only when we have 5y. Because if we divide by 5 in the beginning, we get ourselves in trouble. We get so many fractions.
Oh.
Because we divided everyone by 5. When we divide by 5, we would get, well, let's do that. You see how many terms we have? We have 2 terms on the left, 2 terms on the right. If we divide 5 in the very beginning, we would get 1y plus 3 over 5 equals 10 divided by 5 would be 2y minus 4 over 5. We got 2 fractions. We don't want to do that. Actually, it's okay to do that, but it's just, more work. Does it make sense?
Yes, thank you very much.
Oh, you're welcome. Good questions. Good questions. Keep asking, okay? So we have, first, what's important to identify how many terms we have. We have 2 terms on the left-hand side, we have 2 terms on the right-hand side. When we move, we have to move each term. All right, we have to move each term. And the 5y is 1 term, 10y is 1 term. Okay. So again, let's understand x. By convention, x is 1x, is x raised by 1, is x divided by 1. Someone tapped. Again, so how you're always outside. Okay, just make sure you understand me, okay? What's important is to learn this and to know this to be able to master this material to pass exams, okay? So x, it means 1x, means x raised by first power, means x divided by 1. Right. Oh, hold on, did we talk about this? This looks familiar to me now. No, we didn't talk about this last class, did we?
No, I don't think so.
No, right? Okay, maybe I remember from before because I've been teaching this class over and over. That's okay, Rani. Try not to be late next time. So x plus 2x, that's 1x plus 2x, that's 3x, right? X times x, that's x raised by first power times x raised by first power, which means x raised by 1 plus 1, which is x squared. Right. X minus x over 2, that's x over 1 minus x over 2. Well, there's a 2x over 2 because we need a common denominator. We change the common denominator. So 2x minus x. 2x minus 1x, that's just 1x. In the end, it's just x over 2 or half x, right? Or we can write it as half of x. Let's see this example. We want to solve this equation. 3x plus 7 equals 9. So we have 2 terms on the left, we have 1 term on the right. Now we want to move the 7 because we want to solve for x. So we want to single out this term. So we move 7 to the right-hand side, it becomes negative. So 9 minus 7, that's 2. 3x equals 2. Now we divide by 3 on both sides. So we get a 1x equals 2 divided by 3, which is 2/3. So usually we write it as x equals 2/3. So this we call a linear equation. Again, because the power of x is 1. Non-linear, let's see this one. 3x squared plus 7 equals 9. Well, let's move positive 7 again to the other side. So this is just some review. Let me see. Well, let's solve this one first. So this is a quadratic equation, right? So let me copy and paste. So first I move 7 to the other side. When I move, it becomes negative. So it becomes minus 7. Well, that means it's easier for me to copy and paste. That means 3x squared equals 9 minus 7 is 2, right? So then now we divide by 3, because 3 is a scalar or coefficient of x squared. We divide by 3. We get x squared equals to 2 over 3. Then we square root. When we square root, we get a plus minus, okay, two values. So plus minus square root of 2 over 3. Okay. So let's review. 2 equals 2, of course, right? And we can add, subtract the same thing on both sides. We add 1 on both sides, 3 equals 3, no problem. We add b on both sides, no problem. We minus 3x on both sides, no problem, because they are equations. We always do this, right? It's the same thing as moving around. I like to move things around. And also this is true statement. 2 equals 2, if we multiply 3 on both sides, they stay the same, 6. We divide by 3 on both sides, stays the same. We multiply by x on both sides, stays the same. Divide by b on both sides, b cannot be 0, stays the same, right? So this means when we have equation, we can perform the same operation with the same number on both sides all the time. So we use the above property, right? Let's see, solve this linear equation. Now we have this parenthesis around n minus 3. So what is this 7 here? 7 is multiplying a binomial. So n minus 3, 2 terms called a binomial. That means 7 is a common factor of n and negative 3. So which means we have to distribute 7. We have to distribution means multiplying. We have to multiply 7 with n. We have to multiply 7 with negative 3. Right? So 7 times n, 7n. 7 times negative 3, negative 21. Well, the negative we can put it here, or we can put it inside this. If we put it inside with the negative 3, we have to write plus sign here. But normally we just put it over here, right? So 7n minus 21, then minus 8. Well, minus 21 minus 8 equals negative 15. Minus 21 minus 8, that's minus 29. Right. Then we can move this negative 29 to the right. Move to the right, become positive. Then negative 15 plus 29, that becomes 14. So 7n equals to 14. Now we divide by 7. We divide by 7 on both sides. So that means n equals to 2. Right? So the difference from this one, between this one and the previous one, is we have this. We have a 7 multiplied by a binomial. The 7 is a common factor of the two terms. So we have to distribute. We have to multiply 7 to both of those terms inside. Let's see this one. Left-hand side, we have two terms, 3m minus 1. The right-hand side, we have 5 minus 2 times a binomial. So, which means negative 2 is a common factor of m of negative 1. We have two terms here, right? We have a positive m, negative m1 here. So we multiply negative 2 with m, we get negative 2m. We multiply negative 2 with negative 1, we get a positive 2. Right? So just distribute this negative 2 to the binomial first. Then we see we have 5, we have 2 on the right-hand side. So on the right-hand side, the common term, the like terms. So we can add 5 to 2, or add 5 to 2, get 7. Right? 7 minus 2m. The left-hand side, we don't change. You know, maybe let me do this. It's easier to see it. Right? So this 5 and these 2, I can add them together. That's a 7. So 7 minus 2m. Then I can move this negative 1 to the right-hand side. It becomes 7 plus 1, which is 8. Okay. Then I can move this negative 2m to the left-hand side. It becomes plus 2m. 3m plus 2m, which is a 5m. Or 5m equals 8, we divide by 5 on both sides. So m equals 8 over 5. So far, so good. If anyone has any questions, you can speak up or type in the chat, okay? The next one involves decimals. So this is 0.3m, negative 6.7m, negative 1.6, 5.1. First, let's move things around. Let's move this negative 1.6 to the right-hand side. It becomes plus. Same time, let's move this negative 6.7m to the left-hand side. It becomes plus. So we have this. We have 0.3m plus 6.7m equals to 5.1 plus 1.6. Well, 0.3 plus 6.7, that's a 7. So we get a 7m. 5.1 plus 1.6, that's 6.7. Right? Then we do the same thing. We divide by 7 on both sides. So m equals 6.7 divided by 7. So how do we do this? Because we don't want the answer to be 6.7 divided by 7. So we multiply by 1, and this 1 is 10 over 10. So basically, we multiply 6.7 with 10, we multiply 7 with 10. So we get 67 divided by 70. Right? Okay, we don't want to leave the numerator or the denominator to be a decimal number. Let's see the next one. The next one, the next one, before that, question is this. Oh, next one is this. Next one is another method. Same question, right? You see this same 0.3m minus 1.6 equals to 5.1 minus 6.7m. So basically, this is the second method. Second method is saying, let's multiply everyone by 10. So we have two terms on the left-hand side. We have two terms on the right-hand side. Let's multiply 4 terms by 10. 0.3m times 10 becomes 3m. Negative 1.6 times 10 becomes negative 16. 5.1 times 10 becomes 51. Negative 6.7m times 10 becomes negative 67m. No more decimals. So we multiply by 10 is to get rid of the decimals. Now we move things around. Right? We'll move m terms together. We'll move the constant together. We add up, get this. Then divided by 70, so get same answer. Okay, this is just another way of solving the equations involves decimals. Any questions? Let's see some with fractions. So this is x over 3. Well, x over 3 means 1/3 of x. Because this 3 is in the denominator, means 1/3. So 1/3 of x minus 1 equals half. All right. So that's 1/3 of x minus 1 equals to half. So what can we do? We can move -1 to the other side. Right? Actually, let me go here so I don't have. So x over 3 is 1/3 of x. Let's move -1 to the right-hand side. So I have 1/3 of x, half plus this. Then what's half plus 1? 1 is 2 over 2, right? Half plus 1 is 1.5. It's 3 halves. So it's 3 halves. Now, if we divide by 1/3 on both sides, it's okay, but it's a little bit more work. So instead of dividing, we're going to multiply by 3. All right? We're going to multiply both sides by 3. Because 3 is a reciprocal of 1/3. Because 3 times 1/3 will become 1. Okay, because of this. Because 3 times 1/3 equals 1. We want the coefficient of x to be 1. 1x, right? That's our goal, to solve for x, 1x, which is just x. So we multiply 3 with 3 halves. Well, 3 by itself is just a numerator. 3 times 3, that's 9. So x equals 9 over 2. So when the coefficient of x is a fraction, instead of dividing, we're going to multiply by its reciprocal, or multiplicative inverse. All right, multiplicative inverse. Another thing is, if we have one fraction on the left-hand side, another fraction on the right-hand side, just two fractions, we can do something called a cross multiplication. We can cross multiply. We can multiply x with 2, we get 2x. We can multiply 3 with 3 to get 9. So we get 2x equals 9. So we also get x equals 9 over 2. Right? This is something called a cross multiplication when we have fractions on the right and fraction on the left. Yeah, just remember x divided by 3 is 1/3 of x. All right. One more method. One more method. Let's have, that's one. Okay, let me just copy and paste this. So this is a second method. That's a third method. What do? We multiply by its common denominator 6. All right. So let me change my color. Change my color to be blue. So we're going to multiply 6 with everyone. How many terms I have? I have 3 terms, right? I have 3 terms. I'll just multiply 6 with everyone. 6 multiply x over 3. Do you see that's 2x? 6 minus 1, not 6 minus 1, 6 times -1, that's -6, right? Half times 6, 3. But then I move -6 to the other side, right? I get 9. So x equals to 9/2. So that's the third method, all right? Just like before, when we're dealing with decimals, we multiply by 10, right? We want to get rid of the decimals. Here, we want to get rid of the denominators by multiplying by their least common denominator. So let's see this example. X minus, oh, that's right. So it's the same thing. So let me actually delete this. I don't need this. This is repeated. So let me add this one to here. Right. So multiply both sides by 6, because the 6 is common denominator. Okay, let's see this example. You know, the number just becomes annoying. So what is the common denominator? So we figure out the common denominator. So we have 5, we have 7, we have 35. Well, the common denominator, least common denominator is 35. Right? It's just 5 times 7. 5 is a prime, 7 is a prime. So just multiply those two, 35. Or just multiply 35 for every term. For 3 terms, we have 3 terms. This is one, no. 3/5b is one term. 1/7 is one term. -79 divided by 35 is one term. So we multiply 35 with 3 terms. Well, 35 times 3/5b. 35 divided by 5, because this 5 is a denominator. So we do 35 divided by 5, that's 7. 7 times 3, that's 21. Okay? So that's the calculation. When we do 35 times 3/5, because 35 is also a numerator. So we could think of 35 divided by 5, right? Then multiply by 3. That 35 divided by 5 is 7. 7 times 3, that's 21. So we get 21b for the first term. Then 35 times 1/7, that's 35 divided by 7, which is 5. Then 35 times -79 over 35, well, 35 over 35 is 1. So that's just -79, right? So we move +5 to the other side, becomes negative. -79 minus 5, that's -79 plus -5, so that becomes -84. Then we divide by 21 on both sides, so b equals to -4. Any questions? Well, let's see this example. We have 4 terms, right? 2 terms on the left-hand side, 2 terms on the right-hand side. And we have 2 fractions. So one fraction has a denominator of 5, the other fraction has a denominator of 2. So what's the common denominator? 10, right? So do 5 times 2. Again, those two are prime numbers. If the denominator is a prime number, we just multiply them to get a common denominator. So 5 times 10, 5 times 2 equals 10. So we just multiply every term with 10. 10 times 2/5a, or 10 divided by 5 is 2. 2 times 2, that's 4. So we get 4a. 10 times -2, we get -20. Right? 10 times -4a becomes -48. 10 times 3/2, well, 10 divided by 2 is 5. 3 times 5, 15. Right? Now we move things around. We move -48a to the left-hand side, become positive. So 4a plus 48a, that's 44a. we move negative 20 to the right-hand side. So 15 plus 20, that becomes 35. Then we divide by 44 on both sides. So A equals to 34 divided by 44. 35 divided by 44. Anyone has any questions so far? Okay, let's keep moving. Why this is so big? Okay, so we have a fraction on the left-hand side. We have a fraction on the right-hand side. And the denominator is 2 and 5. Again, the common denominator is just 2 times 5, which is 10. So we multiply 10 on both sides. Right? So common denominator is just 10. We multiply 10 on both sides to get rid of the denominator. So 10 divided by, I cannot change the color inside. 10 divided by 2, that's 5. So we have 5 times 3y minus 6. Make sure you put the parentheses around 3y minus 6. Right? Because this is a binomial divided by 2. This is a binomial divided by 5. 10 divided by 5, that's 2. So with 2 multiple parentheses of 11y minus 4. Then the rest is just solve. Right? The rest is just solving here. Let's not talk about this. So we just distribute, right? So 5 times 3y, 15y, 5 times negative 6, negative 30, 2 times 11y, 22y, 2 times negative 4, negative 8. Then we can move 15y to the right-hand side, becomes negative. So 22 minus 15, that's 7, 7 times y. We move negative 8 to the left-hand side, become positive. Negative 30 plus 8 becomes negative 22. Then we divide by 7 on both sides. So y equals negative 22 divided by 7. If anyone has any questions, feel free to stop me. Let's see some applications. Let's see this. The equation 7x plus a equals minus 13 is true when we replace the variable x with negative 3, x with the value negative 3. It's true. Let's see. So negative 3 times 7 with negative 21. Negative 21 plus 8, indeed, is negative 13. But not true when we place x with any other value. An equation like this is called a conditional equation. All the equations we have solved so far are conditional equations. Okay, just a name. Doesn't matter, all right? So we say x equals negative 3 is the only solution for linear functions. If we have a solution, can only have one solution. So x equals negative 3 is a solution for this equation. We can solve, right? We can move a to the right-hand side, become negative. So negative 13 minus a, that's negative 13 plus negative 8, which is negative 21. Then we divide by 7 on both sides. Negative 21 divided by 7, that's negative 3. But sometimes when we solve equations, we have, let's see this one. So if we have this equation, right, 7y plus 14 equals 7 times parentheses y plus 2. If we distribute this 7 to y, we get 7y. Distribute 7 with 2, we do get plus 14. So indeed, this equation we can simplify, right? We move 7y to the left-hand side, 7y minus 7y equals 0. We move 14 to the right-hand side. 14 minus 14, that's 0. So 0 equals 0 is a true statement. So what kind of equation is this? This equation has infinite many solutions, all right? Because both sides are the same. So the first one is the only solution. Okay, we only have a unique solution. The second situation will have infinite many solutions. Okay, so which means the equation is true for you plugging y to be any number. If you plug any number into y, the equation stays to be true because the left-hand side and the right-hand side equal to each other. Well, some people call it identity equation. Well, it doesn't matter. Well, let's see the third situation. Let's say we have this equation. Negative az equals to negative az plus 9. Or let's move this negative az from the right-hand side to the left-hand side. It becomes positive. Positive az minus az, that becomes 0. So we have 0 equals 9. A false statement. What does this statement say? This statement says no solution for z. Okay. No solution for z. So this equation has no solutions. Okay. This equation has no solution. Okay, no solution. All right, three situations. If we do have one solution, this one solution is the only one. And then if we have a true statement in the end, no more x, we have infinite many solutions. Means every number works for the equation. If we get a false statement like 0 equals 9, that means no solution for the equation. Okay, so three situations. Let me put over here. False statement means no solution. Okay. Let's see this one. This one we could multiply by the common multiple 21. Right? If we do that, 21 divided by 7, that's 3. 3 times 3a, that's 9a. 3 times negative 21 times negative 2 times 21, that's negative 42. Negative 4a times 21, that's negative 84a. 21 times 4 over 3, well, 21 divided by 3 is 7. 4 times 7, 28. Then we can move this negative 84a to the left-hand side. Same time, we move this negative 42 to the right-hand side. So they all become plus. 9a plus 84a, that's 93a. 28 plus 42, that's 70. So a equals to 70 over 93. Only one solution here. Let's see this application. We use linear function applications. When we talk about the triangle, we can talk about the parameter of the triangle, which means we add 4 sides, right? Sum of 4 sides. We also can talk about the area of the rectangle, which is the width multiplied by the length. So in this case, the parameter equals to 2 of the length plus 2 of the width, right? Because we have 2 sides of length or 2 sides of width. So that's parameter of a rectangle. Let's see the question. The question is saying Mika has 74 feet of fencing to make a dog run in his rectangle yard. So what does this give us? This gives us the parameter of the rectangle is 74 because he needs 74 feet to fence it. So the parameter equals 74. He wants the length to be 2.5 feet more than the width. What does this mean? he wants a length L have 2.5 more than the width. So that's W plus 2.5. Or W, or we can write as W equals to L minus 2.5, right? Plus on the right hand side, when we move to the left hand side, it becomes negative L minus 2.5. So then we can make an equation. 2 times the length plus 2 times the width. The width is just L minus 2.5, right? Then equals to 74. Right? So 2 length plus 2 width equals to the function 74. L stands for length, right? W stands for width. Now we have 2L minus 5, because 2 times negative 2.5, that's 5. We have 2L plus 2L minus 5 equals 74 now. We move, so 2L plus 2L, that's 4L. We move negative 5 to the right-hand side, become plus. 74 plus 5, that's 79. Then divided by 4 on both sides. So length equals to 79 divided by 4. Anyone has any questions? We can also use the W to solve the equation, right? Because W equals L minus 2.5. 2W plus 2 length. The length has equals to W plus 2.5 equals 74. So when we solve, we would get the width. Right? Once we have width, we can solve for the length. Okay, keep moving. Let's see this one. So Kim needs to earn $4,150 per month in order to pay all her expenses. Her job pays her $3,475 per month plus 4% of her total sales. So this 4% is her commission. So what is the minimum? What is the minimum Kim has total sales must be made in order for her to pay for all her expenses? Because this 4% depends on her sales, right? So let's make an equation. So she needs this much for month. So 4,150 equals to, well, she makes one time, 3,475. Then the sales, well, let's call her total sales to be S. Right? Let's make a variable S. So over her total sales, she can make 4% of money. So 4% times L. That would be the commission, she earns, right? So let's move this positive number to the left-hand side. It becomes negative. So subtract those two numbers. We get 675. 675 equals to 4%. S. Well, what is 4%? 4% is 4 over 100, right? 4% is 4 over 100. S equals 675. Or we multiply by its multiplicative inverse, or its reciprocal. We multiply the reciprocal of 4 over 100, which is 100 over 4. 100 over 4, which is 25. So we multiply 25 on both sides. Okay. Then multiply 100 over 4 for 4 over 100, we get 1, get S. Then 675 multiplied by 5, we get this number. So Kim has to sell this much, 16,875, to be able to pay all her expenses. Anyone has any questions? All right, let's go to section 2.3. Sometimes when we solve for a variable, we don't really get a value. So above 1, we see, s is a value, a number. Some other variables, we're able to get a number for it. But another situation is, sometimes we want to write the equation in terms of one variable only. So in that case, we also call solve for a specific variable. Let's see this example. V equals 1/3 of pi r squared. All right, let me write this into this form. Oops. To look better, right? So 1/3, 1/3 of pi r squared. Let's change this to be black color. Or I cannot change the color. So in this case, let's look at this equation. Pi is a number. Pi is an irrational number, right? So pi is an irrational number. It's a constant. Pi is not a variable. Pi is not a constant. So what about the variable? The variable we have, solve for pi means write pi. Solve for pi. Okay. In this case, let's see, our goal is to solve for pi. Let me put this over here. Solve for pi. Solve for pi means single out pi on one side or isolate. Solve for pi means write pi in terms of v and r, which means pi is by itself on the left-hand side. The right-hand side is an expression involves v, involves r, because v and r are variables, right? So pi is an irrational number. So what do? First, we multiply 3 on both sides. We multiply 3 on both sides, we get this. Right. We get 3v equals to pi r squared. Then we divide by r squared on both sides. Right. So then pi, so divided by r squared, we get 3v divided by r squared. So pi equals 3v divided by r squared. So you see, solve in this case means, write the variable or the number in terms of the other variables. Let's see this case. We want to solve for r. That means in the end, we want to write r equals to something involves v and pi. We also multiply by 3 on both sides. So we get 3v equals pi r squared. Because we're solving for r, let's divide by pi. So r squared equals 3v divided by pi. Well, this is square. We have a square root. So we get the plus minus 2 values, square root of 3v divided by pi. Okay, we want to keep pi as pi. We don't need to write pi as a number. Let's see this example. So f equals 9 over 5c. Let me rewrite those guys. Nine over 5c, right? F equals 9 over 5c plus 32. And we want to solve for c. Means we want to single out c on the left-hand side of the equation. So first, we move 32 to the other side. Becomes negative. So we have f minus 32 equals 9 over 5c. Now what do? We want to multiply the inverse of 9 over 5, which is 5 over 9 on both sides. We want to multiply 5 over 9, which is the multiplicative inverse or the reciprocal of 9 over 5. Then 9 over 5 times 5 over 9 becomes 1. 1c. 1c, we don't bother to write 1, just write c. Then 5 over 9, f minus 32 times 5 over 9. Right? Or we can just leave like this. 5 over 9 of 5 f minus 32. Okay, that's it. That's perfect. You see, we single out c. Before we have f. So equation is in terms of, so f is in terms of c. Now we rewrite this. So these two actually are inverse function with each other. So solve for c, and c now is represented in terms of f and numbers. Well, let's see these ones. So we have this equation. A equals P plus PRT. How many variables? A1, P2, R3, T4. So we have 4 variables, right? But this is already solved for A. A equals this, right? We have 4 variables, which means we can solve for another 3. Maybe we can solve for P, we can solve for R, we can solve for T. Why don't we do all 3 cases? Right. So this is solve for R. So let's start from solve for R. Then we solve for T. Okay. So RT, and we could try, or you could try to solve for P. All right. So what do we do? Solve for R. So this term has R in it. So we want to single out this term. So which means we want to move this P to the other side, becomes negative. So we have PRT equals A minus P. Equation, we can move the left hand side and right hand side. Then R has scale of P times T. So we just divide by P times T. So we divide both sides by P times T. Then we see this one just left with R. Because P divided by P is 1, T divided by T is 1, which is left with R. And the right hand side we have A minus P divided by PT. Right? A minus P divided by PT. A divided by PT, we can just leave it as that. Then minus P divided by PT, or P divided by PT, P divided by P is just 1. So that's just minus 1 over T. So that's it. So now you see R is solved, right? R is solved, which means R is written in terms of A, P, T. Well, solve for T is the same way. T is with this term. So we move P again. Get a PRT equals A minus P. Now we want to solve for T. So we want to divide by PR, right? Divide by PR. Then T equals A minus P divided by PR. Right? T equals A minus P divided by PR. Then A divided by PR is A divided by PR. Then minus P divided by PR, it just becomes negative 1 over R. So T is solved. T is solved. T, stays on the left-hand side all by itself. And every other variable is being legally moved to the right-hand side. Well, let's all try together to solve for P, right? So A equals P plus PRT. And we have 2 terms has P. This term has P, this term has P. So that means P is a common factor. So let's factor out P. Factor out P, the first term left with 1, because 1 times P is P. The second term is R plus T, R times T, right? Because P is already out. P becomes a common factor. So then now we divide by 1 plus RT on both sides. So P equals A divided by 1 plus RT. So P is solved. T is solved. Any questions? Okay. All right, let's keep going. Okay, I received an email saying this weekend the weather going extreme, cold and windy. So just be careful, everyone. Let's see this one. Solve for h, right? Means in the end we have h equals, a in terms of awk. So h is here, right? Then 2w is a common factor. So which means we need to distribute this 2w first. Or we can just divide by 2w. Let's divide by 2w on both sides. So we get a over 2w equals to this, right? Now we see k is another term. So we just move k to the left-hand side. It becomes minus k. Then we see this is 1 of h. We just multiply by 3, right? Multiply by 3, h over 3 times 3, that's just h. So we multiply by 3 on this side. You'll get this. If you want, you could leave this one as your answer. Or if you want to distribute 3, you write h equals to 3 times a, 3a, divided by 2w, minus 3 times k, that's minus 3k. And that's it. I've seen students make mistakes over this. Okay. So just be careful. Now let's try to solve for w. Right? W is here with 2. And of course, there are different ways of solving it, right? One way is we could split those two things, right? So we put the w outside. We see, okay, w, then put the 2 with this parenthesis. You see this? Right? Because multiplication is commutative, the 2w I can write as w2. Because I'm thinking this 2, I just divide by this 2 times h over 3 plus k. Right? So w equals to a divided by this factor. A divided by this factor. You can leave like that. Or if you want to do some calculation, we have to first we need the common denominators, right? So this will be 3k over 3, 3k over 3, right? Then 3k plus h. So we just change this one to be plus 3k, right? The 1k is 3k over 3. Once we have a common factor, we can add the numerators. So that's h plus 3k over 3. Then that becomes, let me see if I can get rid of this parenthesis. Oh no, I cannot. Oh, this 2. Oh, what happened? If you know the trick, actually this just becomes 3a. So this 3 goes to the numerator place. And this is normal 3 here. So this just becomes h plus 3k. Right? Because when we have 3 layers of fractions, the denominator of the downward one, we can move to the numerator. Because division is multiplication, right? We flip the second one. So when we flip the second one, that becomes 3 over h plus 3k. And that's it. Solve for k. Let's try to solve for k. Well, k is here. So let's divide by 2w first. Then k is here. That means we just have to move h over 3 to the other side. So k equals to a over 2w minus h over 3. That's it. Anyone has any questions? I see students make mistakes. Yes, Ajela, question?
Hi, Professor. Can you hear me?
Yes, I can hear you.
Okay. So for the solving for W, when it was 2W, you just moved the 2 into a bracket, or did you divide by W?
Well, in this case, I just rewrite it. I just change the order of those two. You see, this is a W, 2 times W. In here, I just do W times 2. It's the same, right? 2 times 3 is 6. 6 times 3 is 6. No, 2 times 3 is 6. 3 times 2 is 6. So I can switch the order of those two. Does it make sense? Or without this bracket, do you see this? W2,
Yeah.
W times 2, same as 2 times W. But
Under
because I want to treat this one, I want to divide both sides by this one. That's why I put a bracket here. In this case, I could have just W by itself when I divided by this term.
Understood.
Does it make
Thank you so much.
make sense?
Yep.
Okay. Okay. Okay, let's see this application. The length of a rectangle is 5 inches more than twice the width. So let's call the length L. Let's call the width W. So 5 more than twice the width. Twice the width is 2W. 5 more, just add 5. All right. So that gives the relationship between length and width. L equals 2W plus 5. And then we're given the perimeter is 34. And then we know the perimeter of a triangle. Right? It's 2L plus 2W. Okay, so the formula. So this is the formula. So perimeter is given 34. Then 2W, 2L. Well, this is 2L, right? Maybe I should do this. So 2L, so this is the L, because of this. L equals 2W plus 5. So this is 2L plus 2W. Let's just do the calculation. 2 times 2W is 4W. Right, then plus 2W. So that's 6W. Let me change the order. Oh, I should put this one here too. Right, because 2 times 2W plus 5, that's 4W plus 10. Then plus 2W. Well, 4W plus 2W, they're on the same side, so I can add them. That's 6W. I move this 10 to the left-hand side. 34 minus 10, that's 24. I divide by 6 on both sides, so W equals 4. The length is 2W plus 5, so 2 times 4 plus 5, which is 13. Any questions? Let's see one more example. I think that's it. One more example. So now the parameter of the triangle. So on top is rectangle. So now this time is a triangle. So be careful with that. Triangle has 3 sides only. The first side of the triangle is 1 foot longer than the second one. And the third side is 2 feet longer than the second one. So both comparing with the second one. So find the length of each side. Well, let's call the second side to be S, because the first side compared with the second one, the third one compared with the second one. So let's name the second side to be S. Then the first side would be X plus 1, right? Because it's 1 foot longer. And the third side will be X plus 2, because it's 2 feet longer. Then we just add those 3, right? S plus 1 plus S plus 2 will be the parameter 39. Right, so 39 equals the first side, second, this is second side, first side, third side. Well, that gives us S plus S, S plus S, 3S. 1 plus 2 is 3. We'll move this 3 to the other side. 39 minus 3, that's 36. Divided by 3, S equals 12. Right, so the second side is 12. The first side is 13, because the first side is 1 feet longer. So the 3 sides anyway is 12, 13, 14 feet. The first side, maybe I should put the 13 in the first place, because that indicates the first side. The first side is 1 foot longer than the second. The second we solved is 12. And the third one is 2 feet longer than the second. All right, anyone has any questions? If no questions, that's it. You may go ahead, go to do your homework. I don't know if I have changed the due date of the homework yet. Let's see. It seems like everyone's here today. Right? If you have no questions, you are free bird. Go ahead and do your homework. If you have questions, I'm here. Ask me questions. Okay, you're late. That's okay. Don't worry. You're welcome.
Have a good day.
You too. Have a good night.
Bye.
Bye-bye.